Hello guys, welcome back to Cybernetics. We'll be starting a new tutorial on OpenCV, which is a Python library used for machine learning, and it is also used for image processing. I know, cool, right? Just follow along with me. You'll love this library. It's not as complicated as it sounds like. You can do this with C++ or Python, but I'll be doing this with Python because I'm much familiar with that language. And you don't have to be a master with Python. If you know the syntaxes, it's fine. You'll understand the tutorial. Now let us quickly open a new project and set up the configurations. Alright, now we're done with the setup part. Now we have to install the OpenCV library. Let's open the terminal now. You can do this from your command prompt too, but I'm doing this from my Pycharm terminal because it's much convenient for me to do it. Now write the following code, which is pip pip install opencv-python. You have to replace Python with C++ if you're doing this with C++. This library is already installed in my interpreter, so I don't have to install it again. So I'm getting this message. You people have to do it, or else you'll run into an error. Alright, now let's get started with the coding part. Import CV2. This is obviously used to import the CV2 package into the program. Now let's see how to load an image. Now we're declaring a variable that is image. Now we're calling a function cv2.imread_color. This function is used to load the image in whatever color it is in, and you'll have to specify the location of the source file in its arguments. You can use another function to load the image. This is cv2.imread in small letters. This is much convenient to use because you can specify the way of loading them in the second argument. If you type 0, it loads the image in grayscale, or if it is 1, it loads the image as it is. Now let's display the image that we loaded. For this, we'll use a cv2.imshow function. In this imshow function, it has two arguments. In the first argument, we'll have to pass the name of the application. We get a display application when we try to show the image, and we'll have to give it some name. I'll name this photo. And in the second argument, you'll have to pass the variable which has the image, that is img. Now we'll use a function cv2.waitKey. What this function does is it waits for a certain amount of time that we specify in its arguments. This argument takes your time in milliseconds and waits for that certain period of time to close the application. If you put 0 in there, it waits for infinite amount of time. Now we specify a function cv2.destroy all windows. This is used to close all the windows that are being used by this program. Now let's run the program and see what we get. As you can see, we're getting the output in grayscale because we specified 0 in the second argument of imread function, which is supposed to load the image in grayscale. Now let's try and do some operations on the image that we loaded. We'll start with resizing the image. For resizing, we use the function cv2.resize, and we'll have to specify the variable that has the image in it in its first arguments, and then the dimensions in the second one. Let's run the program. You can see that we're getting the image in its 400 into 400 dimensions. You can resize the image according to its ratio. For that, you'll have to make the dimensions 0, and then in its third arguments, you'll have to specify the ratio of its x-axis and its y-axis. And For that, you'll have to use fx and fy. These are predefined. Now let's run the program. You can see that image is being displayed in its altered ratio. So that's how the resize function works. Image, dimensions, and ratio in its arguments, respectively. Now let's do some rotate operations on the image. For this, we'll have to use the function cv2.rotate, and in the first argument, you specify the source file, and in the second one, you'll have to type in cv2.cv2 dot capital rotate underscore 90 underscore clockwise. What this does is it rotates the image 90 degrees to the clockwise direction. There are two more options. You can check them out, which are rotate 180 degrees and rotate 90 degrees anti-clockwise. Let's see what the program does. You can see that we're getting an image which is rotated 90 degrees to the clockwise direction. Now let's try rotate 180 and see what it does. And the image is rotated to 180 degrees. Now let's see how we save an image that we did the operations to. We use the imwrite function here. We specify the name of the file that we're going to save in the first argument and the file that we did the operations to in the second argument. Now let's try and run the program and see what it does. Oh, I guess we've run into an error. Let's see. Okay, I've checked the error. What mistake we did was we did not specify the file we're saving it as. We have to specify that we're saving it as a JPG file or as a PNG file. Now as you can see, we're getting the output, and also you can clearly see that the file has been saved in the project. So that's it for this video, and we will meet again in the next video, which is image manipulation.